We're now going to look at a related rates problem that involves a ladder sliding down a wall. We are told that a ladder 10 feet long rests against a vertical wall. The bottom of the ladder slides away from the wall at a rate of 2 feet per second. We want to find how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall. I went ahead and drew our diagram. This is our wall. This is our ladder. And then we'll just call this the ground. The bottom of the ladder is moving this way, and then the top of the ladder is moving down this way. Before we write down what we're given and what we want to find, we have to assign variables to our picture. I am going to let this distance be x, this distance be y, and then we're told that our ladder is 10 feet, so we'll make the hypotenuse equal to 10. Now let's see what we're given. We are told that the bottom of the ladder slides away from the wall, so that means dx is going to be changing with respect to time at a rate of 2 feet per second. And we want to find how fast is the top of the ladder sliding down the wall. That means that y is going to be changing with respect to time. And that's going to be when the bottom of the ladder is 6 feet from the wall. So that's when x is equal to 6 feet. And then now we have to find an equation. We need to find an equation that is going to relate x and y. We have a triangle, and this angle is 90 degrees, so we can say that x squared plus y squared is equal to 10 squared. We'll go ahead and put that this is x squared plus y squared is 100. Now we're going to go ahead and we'll take this equation and we are going to differentiate it with respect to time. We have d dt of x squared plus y squared is equal to the derivative with respect to time of 100. On the left, we have 2x times dx dt, and then we have 2y times dy dt, and that is equal to 0. We want to find dy dt, so let's go ahead and solve for that. Dy dt is going to be minus 2x dx dt, all divided by 2y. So this is minus x times dx dt, all divided by y. Let's go back up here to the top. We want to find dy dt when x is equal to 6 feet. So let's go ahead and put this down. We want dy dt when x is 6 feet. Now let's go ahead and let's look over here at our equation. We have an x in our equation, but we also have a y in our equation, and we don't know what y is. So we have to use our equation here that relates x and y to find what y is when x is 6 feet. So I'm just going to say we need to find y when x is 6 feet. So we have x squared plus y squared is 100. Let's plug in that x is 6. So we have a 6 squared plus y squared is 100. So this gives us y squared is 100 minus 36, which is 64, and that's really nice because the square root of 64 is just 8. Now we can go back up and say that when x is 6 feet, y is 8 feet. And we can go ahead and plug this in. So we have a minus x, so that's a minus 6 feet, times dx dt. We have to go back up. That is 2 feet per second. So we'll plug in 2 feet per second. And then we're going to divide this by y, which is 8 feet. This gives us a minus 12 over 8 feet per second. We can divide both of these by 4, so we end up with minus 3 over 2 feet per second. When you are solving related rates problem and you get a negative for an answer, what you need to do is go back up to the original problem and find out exactly what you're being asked to find. We want to find how fast is the top of the ladder sliding down the wall. The word down takes the place of the negative. So in our answer, we need to not write the negative and instead just say that the top of the ladder is sliding down at 3/2 or 1.5 feet per second. And I'll go ahead and highlight that answer.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.